Unit 1 Chemistry, Chapter 4, Ionic Compounds. So, the properties of ionic compounds, first of all. When we see ionic compounds, we will find that they have high melting and boiling points. Normally, melting points would be in the thousands of degrees. They are very hard, but they are brittle. Okay? What that means is if I take a big lump of them and I whack it with a hammer, it's going to break apart. But if I try and scratch it and leave a mark, I will be unable to. When they're solids, they don't conduct electricity, but when we melt them or if we dissolve them, then they will. They are made up of cations, which are positively charged, and anions, which are negatively charged. You may wish to go onto the PowerPoint and follow this link, and there's a little video which explains ionic bonding to you and how they're arranged. Okay. In an ionic compound, the anions and the cations always combine in the correct ratio to make sure the result is a neutral molecule. And we get electrostatic forces that hold the ions together in a lattice when they're solid. An electrostatic force is a force which is between something positively charged and something negatively charged. So we'd say it's an electrostatic force between a proton and an electron. We also say an electrostatic force between an anion and a cation. Okay. So they're arranged kind of like this. Exactly like this would depend on what you've got in there and the ratio. Okay. But essentially, if this is our chloride ion in sodium chloride, each chloride is surrounded in all dimensions by sodium, and each sodium is surrounded in all dimensions by a chloride. Okay, so you get alternating anion, cation, anion, cation. Okay. In the case of sodium chloride, each sodium ion's got 6 chloride ions around it, and each chloride's got 6 sodiums around it, because it's a 1-to-1 ratio. So, they are hard because those electrostatic forces are very strong. So you need a strong force to disrupt it. So me trying to scratch it with a nail or something isn't going to break those bonds. It's just not enough force. However, if I give it a strong force, what that's going to do is shift the layers in the lattice. So if I take all of these and I shift them one position to the right, what's going to happen then is that instead of my chloride being surrounded by sodium, I've got a chloride next to a chloride. Now they're both negatively charged. And I've got a sodium next to a sodium, and they're both positively charged. And what we're going to find is that they repel each other because they don't like each other. Go, get away! And they physically will force each other apart by a force of repulsion, the opposite of the attractive force that we normally see in the ionic lattice. So that makes them very brittle. The identically charged particles repel each other, and that shatters it. In terms of electrical conductivity, when they're like this, in a lattice, they can't move. Okay, these forces are really strong. Because they can't move, they're not going to conduct any electricity. But if we dissolve it, then we separate them into free ions. Similarly, if we melt it, then we are breaking these electrostatic attractions and they can move around freely. Okay, so because of that, the ions, the positive and negative ions, can move and conduct electricity. So if you put it in an electrical circuit, the anions are going to move towards the positive terminus because negative is attracted to positive, and the cations will move in the opposite direction towards the negative terminus. Okay? It doesn't have to be electrons that conduct electricity. To conduct electricity, you need something that can move and has charge, and ions can be that something.